Welcome back to Ratty Tutorials. In this portion of the series, we're going to be going over how to transfer files to the Raspberry Pi over FTP, and then we're going to start to get into the HTML code and PHP code that I've written that integrates with a Python script and sends a hash over to the microcontroller. So, up to this point, let's see. Alright, so if we're going to FTP, which stands for File Transfer Protocol, to the Raspberry Pi, so this is how we're going to transfer files over. So I have in my folder here a couple files that I've already written in index.html, and I want to transfer them over to the Raspberry Pi. You're going to do that using a piece of software called FileZilla. So go ahead and download that. Now to connect to the Raspberry Pi, we gotta first create a profile. So we go to a new site, and under host, type in your IP address. And then we're gonna go over SSH file transfer protocol right here. And normal login type, and then your username and password. So mine was garage, and then door. We'll hit OK, save that profile. And now we should be able to connect to the new site. Boom, I'm in. So this is my Raspberry Pi. So I want to transfer these files into my server's location from my Apache server. So remember, that's going to be in var down here, www, html, and there's my old index.php. Remember from my website. Right here. So that's what that index.php is. So we're going to delete that, and then we're going to move over some of our files. Just those. And it's saying permission denied because garage door does not have permission to write files to this location. So, the profile garage has permission to write into only his directory, which is in home, and then your username right here. So he has permission to write into here. So we're going to transfer the files into here, and then we'll use a sudo command to transfer them over into var www.html. Alright, so files are in there. Go ahead and SSH into your Raspberry Pi, and you should be able to see those. Okay, boom, they're right there. So I just transferred those over from FTP. So I want to now do sudo move. Star means everything in this folder, and then I'm going to move them to var www.html. So I'm essentially moving 4 files at once. Okay, if I list again, they're gone because I moved them. So let's cd back into your Apache server. Okay, cool, they're all in there. And then you can do ls tac l or al like that. And you can see that these files, their owner is garage. Hopefully that doesn't cause any issues, but we'll see. Okay, so let's go ahead and remove index.php right here. Remember, we don't need that anymore. Do sudo remove index.php like that. Alright, now we have all the files, so let's go ahead and look at the website I wrote. Okay, here we are. So, in website security, or cybersecurity in general, there's a thing called security through obscurity. And it's a concept that you hide the intentions of your website or something like this. So I've created a website that's all about, hey, create your independence flag, but in reality, whenever you type in the correct input into all of these numbers, then that is what's going to open up the garage door. So if a hacker jumps onto your website, they're not really sure what to do with this website. And so that's called security through obscurity. So, let's see, what we're going to do right here is, input a date. Just put a random date in there, and then you can choose color for your flag, green, orange, and then feet for how long you want your flag. So something really weird, something simple, but what this is doing is creating a lot of different inputs that is going to be incredibly difficult to guess the correct password. It's essentially your password. So you create your inputs and you hit make flag. Boom, you just generated your Independence Day flag. And what that did now is it generated a hash based off of all of those inputs and then sent it over UART on the Raspberry Pi. So let's dig into the code and see how this works. So here on the left we have code for index.html, which is what you see right here. So we're just going to go line by line reading through it. So we have create your Independence Day flag right here. And remember, for all this code you can download it on git.raditutorials.com and you can follow along with the code. Alright, so we're going to create a form, which is essentially input, and your form, upon completion of your form, it's going to send information over to generateFlag.php, and I'll tell you why in a minute. And then your method, you're going to use a post method, and then on input, this is for the slide bar right here to make it work correctly. Which essentially allows this number to be updated in real time as you slide it through, which I thought was a helpful feature. Okay, what is your Independence Day flag? And then here we're getting into input now, your first input, which is the date. This is the calendar right here. So whenever you go to this website on a Android phone or an Apple iPhone, the calendar is going to look very different depending on how your device handles it. But it's really cool how they change. So on a Windows machine, this is what the calendar looks like, but it's going to look very different if you open this website on your iPhone. So I'm creating a type date, which makes the calendar, and I'm going to give it a name. I'm going to call it capital I and then date. Okay, and then color of your flag. So now I'm creating some checks boxes, which are essentially true or false, and that creates more random input. So we have different colors right here, and then how long is your flag in feet. And you can create this range to be quite significantly a large range. It could be hundreds of numbers, but I just chose 5 to 15. Essentially, you can rewrite this entire website to be completely random, up to your desires, and then whenever you hit make flag, you can generate a hash based off of your random input for your password. Okay, and then your output, which is this guy right here, is right here. And so then input submit button right here, it's called make flag. Once you hit that, it's jumping over now to generate flag.php. So let's look at this code. So you only see this right here, Independence Day flag, and then your image right here. Everything else is code that is running in the background. So if you were a hacker looking at their website, you could inspect it, and you could look at their code, and all the code you see is that, oh, they generated a flag, and they have some text right here. But what the hacker doesn't see is all this extra PHP code right here, which is executing stuff in the background. Okay? So what it's doing is now I am grabbing all the values that we wrote into based off of their names, and I'm putting them into values in PHP code. So you're transitioning between HTML code and PHP, and these are just certain commands that you can use to do that. So I'm going to create a value name called VIday value, and then I'm using the post command to grab that value from the form. So this is from the calendar, and then this is all Boolean values, true, false, that I grabbed from all those 4 different colors, and then the flag size, which is just a number between 5 and 15. So then bin hash, these are going to be the values, and the dots right here just concatenates them into one long string. So it's going to be the calendar date, Boolean 0 or 1, true, false, and then that's what's going to allow me to create a hash based off of a string. and then this shell command, I'm going to run it through shell, and I'm going to say sudo python, here's my Python script, flagwave.py, spacebar right here, and then I'm writing my value, which is considered an input into that Python script. So I'm essentially inputting this long string into a Python script, and my Python script is going to take the hash of that string and then send it over to your MSP430 or Arduino microcontroller, which decides if that's the correct password to open up the garage door or not. And then for output, this is kind of like the last command you have to run. It says shell execute and then this shell command right here. Alright, so if I wanted to show you how to exactly what this string looks like right here, we might be able to run a command. Let's give it a shot. Echo, and then let's echo bin hash. So maybe we can kind of see what this string looks like. So I saved it, or actually let's edit that in the Raspberry Pi. So I'm going to go sudo nano, and let's edit the generate flag.php. So in here, let's try echo. Whoa. I'm going to echo bin hash. Let's see if this will work. Okay. Exit save. Now if I go back to the website and I just rerun this, didn't work. It didn't work because I need to go back and rerun this. So let's hit submit form again. There you go. So this is essentially what the string looks like. So it's the date, the year, the month, the day, and then the Boolean values, true or false for the colors. So it's the first color, second color, third color, fourth color, and then the feet of the flag right there. So this is one string. It's essentially your password, so don't ever let anybody know this password right here. And then I'm going to generate the hash of this. Okay? So let's jump over to the flagwave.py. So this is the actual Python script, and this is the last thing that gets executed on your Raspberry Pi. So I'm importing a new library called hashlib from MD5. So I'm taking the MD5 hash of this string. You should look up MD5 in Wikipedia and read a little bit about it. It's some interesting stuff. It's not the most secure hashing algorithm, so I recommend using SHA in the future if you want to make this really secure, but MD5 is really fast. And we're going to also import sys and then serial, because we'll be sending the hash over the serial interface, which is also called UART. And UART is pronounced like that, and you should look up UART too and learn about it's a communication interface. Okay, so what we're covering again right now is this Python script right here that's sending information to the microcontroller. So we're going to talk about this communication right here. So we are inputting a hash, MD5. This is kind of like initializing this value right here. And then we're going to input a string, and we're going to take the first argument. So sys.argument value 1. Remember how right here, let me just run this for demonstration purposes. We ran this command sudo python, the Python script, and then we're inputting a string value in it, this one right there. So this is what is being executed on your Raspberry Pi. And then, so it's saying take the first argument, number 1 right here. It's saying take this argument right here and input it as a string. Okay? And then I'm going to encode that string into UTF-8. You can look that up, reasons why you're doing that. And then we're going to remember this initialized hash value right here, we're going to update it because it's essentially a null right now. There's nothing in it. We're going to update it with the encoded version of this string right here. And then now we can output the hash. So this is all really confusing. Took me a long time to figure out how to get this to finally work, but this is how it works. So you take a new value called output hash, and we're going to take this hash and we're going to convert it to a hex digit, and this is what is going to be sent over the UART communication line. And so I tried to send just input hash over the communication line, but it got really messy. So we're going to do this. Alright, and now we're creating a serial interface instance, serial.serial, that we already imported up here, and this is just what you need to do for the Raspberry Pi. You can look up how to initialize the UART interface on the Raspberry Pi, but this is what I've grabbed from other websites. And then I'm going to set its baud rate, which essentially is how fast it communicates, to 9600, and that's pretty standard for most UART interfaces. And then the final command, serial.write, and then my output hash. Okay, and so this is going to send the hash over to the microcontroller, and it's going to determine if it's correct or not. So now if you're ever wondering what the actual hash value is going to look like, we can actually see that right now. So I don't have a command in here that tells to display the hash value because for security purposes, but we can actually jump into the script and tell it to do that now. So let's do sudo nano and let's jump into the Python script. Okay, so we're now in the Python script, and let's edit something at the very end. We'll call it, what's the command? Print, and we're going to print the output hash. That should work. Let's give it a shot. So before you can actually get the UART communication interface to work on the Raspberry Pi, you have to activate it. So we can activate this running command called sudo rasb.config, just like that. Takes us here, and we can go to advanced options. Then we're going to go to serial right here. Yes, serial has now been enabled. Alright, we hit finish. Once you have serial installed, you have to install another module package to be able to interact with Python. So we can run sudo apt-get install and Python serial. So now we can actually run this Python script just like we're doing in our PHP website. So for PHP, we're running this command right here, sudo python, the Python script, space, and then this is the argument that we're adding to it, the bin hash. So let's do that. So we're going to run sudo python flag wave.py, and then we're going to put an argument in, and this is the string that's going to get hashed. So we did 2016 07 13 01109, and this is what the hash looks like, this random gibberish. So now what's interesting about hashes is that no two inputs are the same, or at least theoretically. So now if we change one of the colors, so let's say the first color, which was what, red, so this is 0110, that's the four colors. So if we changed one color to 1, so all we've done is changed one value from 0 to 1, and we rerun the hash, it's two completely different hashes. See? Now if we rerun the same command as this one right here, it's always going to be the same value. So these two hashes are the same, but these two hashes are very different based off of one value change. So that's why this is a little more secure for doing GarageFlow projects, because based off of your password right here, it's going to generate a new hash. And this is the value that gets sent over to your microcontroller. So let's see what we've covered today. Covered how to log in to FileZilla, transfer some files. Make sure you transfer to your home directory first, and then using sudo on SSH you can transfer files from your home directory into the web browser or server location. We went over the HTML and Python scripts. You can avoid brute force attacks by making your website generate a lot of different values. So I have a calendar, a couple colors, and then these numbers right here. That's not a very long password, but if you added, many more values here, then it's going to be very hard for a hacker to try every single one of those combinations. We went over the Python script to understand it, and then we generated a hash from the input. And so now in the next lesson, whenever we actually write code for the Arduino or MSP430, you're actually going to need this hash value to input into that. So go ahead and pick what you want your finalized password to look like. It could be a date back in, let's see, how do you go back far here? Oh, you scroll right here. So we could go all the way back to, let's go far. Oh man. Let's go back to 1976, March 10th. So March 10th, 1976, my flag was blue and orange, and it was 12 feet tall. Like that. So that's what the value is going to look like, and then I'm going to run the hash of it. So we're going to say back in 1976, 03. So that's my finalized password, how I'm going to log into my garage door and open it every single day. Hit enter. This is my hash, which is completely different than the ones before. So that's my password that I don't want anybody in the world to know. But anyways, that's the value that you're going to transfer over into the next lesson. But in the next lesson, we're going to cover the microcontroller, how to write the code for it, what it does with this hash, how it accepts it or rejects it, and then essentially opens up your garage door. I hope you will join us. Thank you.